Hello friends. So today we are going to solve this question. So this question was requested by one of my subscriber. So here z is equal to given. This is z, and we need to find del z by del x, del z by del y, and also we need to prove this. Okay. So let me take a new slide and let me solve this. Before we solve, please subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you. And if you want to follow me on Insta, this is my Insta ID, Oza, OZHALAKHY, 123. This is my Insta ID, so you can follow me on Insta. Okay, so now let's start. So what is given here? Z is equal to this. This is Z. Okay, so let me take this as equation number 1. So first what we need to do, we need to find the partial derivative of z with respect to x, right? So before we find this, so let me take that del z by del x, okay, of f of x. Let me consider that is equal to partial derivative of a function f of x, let it be f dash x, and partial derivative of f of y with respect to y, let me consider this way, f dash of y, right? Let me consider this way. So now you see, first what we're going to do here, number 1, here the z is nothing but e to the power ax plus by into f of ax minus by. Okay, so here we're going to use the product rule. This is u and this is v. Okay, we're going to use that product rule. So if we use the product rule, so derivative of first function, this one, its derivative will be given by e to the power, we know that ddx of e to the power x is e to the power x. Its derivative is e to the power x. But here we have e to the power ax plus by. So again we need to differentiate this as well. E to the power x, that means e to the power ax plus by, its derivative will be e to the power ax plus by, and also derivative of ax plus by should be taken. If you differentiate it partially, then this term gonna give you a, and this term gonna be 0 because this is function of y. So that's why what we're gonna get, derivative of ax plus by is nothing but a. So here we're gonna get a. Then second function, f of ax minus by. Now first function plus first function, which is e to the power ax plus by, derivative of second function, derivative of this one. So as we have already assumed that del x of f of x is f dash x, suppose. Okay, we have already taken that one. Okay, so in that case, instead of x we have this one now. Okay, so if that is the case, derivative of this part should be f dash of ax minus by. But here you see, this is function of x, but here it is function of function. This is function of, again, another function, ax minus by. Again we need to differentiate with respect to x. We need to differentiate ax plus, not plus here, in this case minus by. And if you differentiate it, it's gonna give you a, and this is gonna give you 0 because this is function of y. So that's why again we're gonna get here a. So this is a. Let me write here. Okay, now here you see we can take these two part common, right? So if we take this common, then what we're gonna get, this result gonna give us a e to the power ax plus by. Within bracket we're gonna get f of ax minus by. Then we're gonna get plus f dash of ax minus by. That's what we have got, right? So this is what? This is del z by del x, right? So now let me find del z by del y. Let me go to the next slide. Okay, so here you see number 2, number 2. So let's find del z by del y, and z is nothing but e to the power ax plus by, which is given into f of ax minus by. This is given, okay, z. So which is equation number 1 we had taken. So now you see, if you differentiate it again we're going to use the product rule, but this time we are differentiating with respect to y, and derivative of the first function, derivative of u, that is e to the power ax plus by, as it is function of function, let us differentiate this power also. So then you're going to get b, because derivative of ax, that's going to be 0, because we are differentiating with respect to y partially, and this part is function of x, right? Then second function, that is f of ax minus by, right? Then plus, now second function, first function, that is e to the power ax plus by, derivative of second function, as we have taken del y of f of y, it can be written as f dash of y, but here it is purely a function of y, but in this case here you see this is function of x and y. So that's why here you see derivative of this part, second function, will be given by, let me just let me get some space here. So derivative of this will be given by f dash, according to this, f dash ax minus by. Then again we need to differentiate this part which is within bracket, so that's going to give you, derivative of this with respect to y, this is going to be 0, because this is a function of x, and derivative of this is going to be minus b. So that's why what we have got here, we have got minus b, right? So hope you have understood this. Now let me clean these things. Okay, so now this can be written. Now you see, you can take you can take b e to the power this, you can take common. Okay, this part can be taken common. So on taking common, what we have got, b into e to the power ax plus by, within bracket what we're going to have, f of ax minus by, and this negative sign, and this is positive sign, that's going to give you minus f dash of ax minus by. That's what we have got. So this is the result. So this is what, del z by del y, right? So now you see, now third one, we need to prove this relation. Okay, we need to prove this relation. How to prove this one? So now in that case, we're gonna need both the results, del z by del x, del z by del x. Let me copy this result. Okay, here, and we're gonna need this one as well. So let me copy here, number 3. This one, first one, right? And also we need this equation number 1 as well. What was that? Equation number 1 was z is equal to e to the power ax plus by into f of ax minus by. We need all these 3 results. So let me take, this is equation number 2, and here you see this is equation number 3. Okay, so here this was equation number 1, this is equation number 2, right? So you don't need to read this one, write this one again. This is already, you have given equation number 2, but as I am using different slides, so that's why I have written these equations again. Okay, so you have already mentioned 1 and 2 here, so that's why you don't need to write again. Okay, just mention this is equation number 3. So that's it. So now let us take the left hand side. What we need to prove? We need to prove this one. So now let me take the left hand side. What is the left hand side here? You see, left hand side, that is b into del z by del x plus a into del z by del y. Okay, this is the left hand side. Now let me use the results of equation number 2 and 3. Okay, if we use these results here, then we're gonna get b into result of 2 is this. So let me put this one here. This is what, that is del z by del x, right? So now let us replace this del z by del y by this result. So if we replace that, plus a into, and del z by del y is this. Here you see, this is the del z by del y. Okay, let me use this result here. Okay, so now just wait, let me write these things here on this side. Just wait. Okay, let's keep this way. Okay, let's keep this way. So now you see, so this is what we have got. So now again we are to take this a b e to the power ax plus by common from both terms. So if you take this common, then what are you gonna get? Then let me write here, just so then you're gonna get here, sorry, this is equal to, instead of ba, let me write ab. Okay, a b, then within bracket you're gonna get these things. Let me copy this and let me paste it here. Then plus you're gonna get this thing. Okay, let me copy this. Okay, let me paste here. So this is what we have got. Now let me copy this result. Let me go to the next slide. Okay, so here is the next slide. This is the last step we have got. This is the left hand side of number 3. Okay, so now what we can do here, you see these two cancels, right? These two cancels. So we ended up with this e to the power ax plus by, and there are two f of ax minus by. Okay, so here we're gonna get 2 here, just wait, 2 into f of ax minus by. So here we can write 2 ab e to the power ax plus by into f of ax minus by. That is what we're gonna have. Now you see, from equation number 1, this part is nothing but z. Okay, z is equal to e to the power ax plus by f of ax minus by. That was equation number 1, right? That was equation number 1. And let me write one more thing. So here I have used equation number 2 and 3. These two equations are used. So do mention here using equation number 2 and 3. Okay, 2 and 3, right? And here you see, we're gonna use equation number 1 here. So replace it by 1. So then 2ab is equal into z. Okay, using 1. So this is the right hand side we needed to prove, right? This is the right hand side. If you check, let me go to the equation. So here you see, this is the right hand side, 2abz. Okay, that's what we have proved. Okay, so hope you have understood this. Thank you for watching. See you in the next video.